All right. Good morning, everyone. Just getting a little organized. Give me a second. All right. Again, good morning. I just want to make a few reminders that, excuse me, our test 2 is in my math lab. It is due this Friday. That is Friday the 3rd, and this is not an April Fool's joke, haha. By midnight. I have not seen one single person do that yet, and that's understandable. I see that most of you are still working on your homework, still working on the review, but I'm also seeing very, very low participation in the homework and the review, and I'll even say out loud, only 4 people have started the review at this point, or at least have grades in for them, some grades, that is to say. So you have got to take this serious. These deadlines are serious. I know that my math lab was down for about 24 to 36 hours, but that was over the weekend for the most part with a little run into Monday. Everything's fine now. So please, please, please make sure you're getting this stuff done. So homework is due on Thursday by midnight. Test is due Friday by midnight. Remember that the review will not count as a grade. You might be able to notice that it is omitted in the grade book, so don't worry about that. If you don't complete the review, if you're just doing it pencil and paper, that's fine as well. But I do suggest doing the review in my math lab, since it'll be even more practice getting those answers in my math lab correct. And remember, the test is only 15 questions, where the review is like 25 or 26 questions roughly. So you'll see a couple, maybe like a couple duplicates, or just a little more variation in the review. So last time we got into chapter 7. We started 7.1, but we did not finish it. I would say we didn't even come close, because we still have the hardest problems to tackle. And we said that we were dealing with oblique triangles, no longer right triangles. So all the triangles in chapter 7 are not necessarily going to be right. It's extremely rare that they'll be right. And we said that there's 2 main cases of this, and it's all of the angles are going to be acute, which means they're less than 90, or you might have one angle that's obtuse, which means more than 90, and that forces the other 2 to be acute, and that there was no way for 2 to be obtuse, because 2 angles that are bigger than 90 would not form a triangle, which has a maximum internal angle of 180 degrees. And we said that when you're doing these oblique triangles, you have to avoid the Pythagorean theorem. It does not work, because that requires a 90-degree angle somewhere. And we also said that as long as we're given half the components of a triangle, so 3, we can find the other 3 by using trigonometry. We went through examples of the 2 easiest cases where we were given 2 angles and a side, and it didn't matter where the side fell. We could always find the third angle by doing 180 minus the first and the second. And then we can find the other, another side by using the law of sines, which we said that, give me a second. Again, that was A over sine of angle A is equal to B over sine of angle B is equal to C over sine of angle C. That's our law of sines. It's an interesting law because it's a 3-sided equation. It's not very typical, but it just means that we can use any 2 of the 3 and make our own proportion out of it, cross multiply and solve for whatever's missing. So the easiest case is when you're given 2 angles, there's always one solution. It can't be anything else. It's impossible geometrically. But then we also had the ambiguous case, which was when we're given 2 sides in an angle, and it had to be side-side angle. In other words, we're not given the angle between the 2 sides. So we'll see this SAS case in the next section, and I even mentioned that we'll be using the law of cosines for that. So with this ambiguous case, we had some drawings that I'm not going to take the time to redraw because that's another 10 minutes of our time. So go back and look at those drawings from last time over how to tell if there's no solution, one solution, or two solutions. And again, it's not, drawing the picture isn't going to tell us that. It's the math that'll tell us, because when we draw the picture, we don't know what we're looking at. And those diagrams are also in your textbook in 7.1, in the ballpark of page 738, 739, something like that, but it's in 7.1. You'll see those same three triangles that we drew. So how do we approach this ambiguous case, which we've done one example of? We determine the second angle by law of sines. So you have to be given a completed pair, the angle A and the side A, or the angle B and the side B, or the angle C and the side C. That has to be given to you. You can use a completed pair to use the law of sines to then find an extra piece of information. So we'll determine the second angle by law of sines. Once we have that second angle, the supplement of it would be the second version of that angle that would make the second triangle. And that's the possibility of it. So if there's a second triangle, the second version of the second angle would be the supplement of the original version. And again, this can all be shown by drawing diagrams that exist in your textbook. So once we have the second angle, take a supplement. So if the original angle is 10, then the second version of that angle would be 170. If the original angle was 30, the supplement, the second version of it would be 150. Now there's always a supplement, but that doesn't mean that it works. You have to make sure that this is possible. So you take the original first angle given, the second version of the second angle, aka the supplement, and if you add those and it comes up to less than 180 degrees, that means there is a second triangle, and you'll have to have second versions of all the information that was not prescribed to you. Any number prescribed to you, that's it. There's only one version. But it's those other ones that there can be second versions of. And we will see two examples of this today. So again, this is our process. Determine the second angle, take its supplement, and then see if that fits with the first angle. If it does, second triangle. If not, it's easier. All right, so let's pull up our whiteboard. And we're going to be doing example 2B. This will be find all remaining info. Let's say sides, angles. And we did A last time and it came up to no triangle. Oh, I did download a TI-83 app, so I'll show you the input of that, how we did see that it was no triangle. But let me finish example B first, since I'm already on that. So A, little a is going to be 30. Then little b is going to be 20. And then angle A is going to be 50 degrees. There we go. So find all remaining sides or angles. Now, this is the side-side angle case. This is side-side angle, because we have a completed pair and we're only given one angle. If we were not given a completed pair, that means that the angle given to us would have to be between these two sides. So if you want to draw up your triangle, and again, this is an assumed form, it's not necessarily going to look like this. Angle A is 50 degrees, so here's our 50 degrees. I like to put A in the bottom left. B, so that means this side is 30, then the B is 20. I'll make this side the B. That's pretty typical with these, which makes this angle B, this angle C, and this side C. So we can see that the angle is not between the two given sides. So if we knew angle C and not A, that would be SAS, side, angle, side, no matter which way you approach from, side, angle, side. This is SSA, side, side, angle. Now you might say, well, if you go the other way, it's side, angle, side, but you're skipping a whole bunch of stuff. And that's why we have to go counterclockwise in this instance. And again, the naming aspect of this is really not that important. No teacher is going to test you on what the case is, in my opinion. It's understanding whether there could be two triangles or not. And this is the case. Two triangles are possible. All right, so we have the A's completed, so we're going to use the law of sines with the A's. So we're going to go 30, that's the little a, over sine of big A, that's sine of 50 degrees, equals. Now, I don't have anything about the C's, so we have to go after the B first. So we're going to use the little b, which is 20, that's the side length, over sine of angle B. Okay, cross multiply, and we'll get 30 times the sine of angle B equals 20, that is a 2 there, times the sine of 50 degrees. And now we're trying to solve for B here, this capital B, but it's inside the sine, so that's going to be a little more complicated. And that's exactly what happened with 2a last time, if you remember. But we still got to clear the 30 first. So we got to divide both sides by 30. So that the 30s cancel on the left, and we get the sine of B is equal to 20 sine of 50 degrees over 30. Now, typically these numbers right here are not going to reduce, but in this particular problem they do, so why not reduce it if we can? So that's going to become a 2/3. You can't reduce an angle with the side length, though. Don't try and reduce the 50 with the 30. That's impossible. So we got that sine of B is equal to 2 sine, oh, I need to give myself some more room. There we go. 2 sine of 50 degrees over 3. Now, some people will go ahead to the conclusion of this. Some people will show the algebraic step. It's up to you what you do on your own work. But if you have sine of B equal to something else, then you can solve for that by taking the inverse sine of both sides. So take the inverse sine of both sides. And what that will give us is that B, because these will cancel out as long as we're in the appropriate quadrants, which we have to be, equals inverse sine of 2 times the sine of 50 degrees over 3, and we want to make sure that we keep that in parentheses. And again, if you didn't reduce the 20 and the 30, if you still had 20 over 30 here, that's perfectly fine. The reduction is not necessary since we're going to jam this in a calculator anyways. All right. So here's my nice TI-83. Hopefully everybody can see that. Let's power it on. This is going to take me a little longer to type with using a mouse, so please be patient. Check your mode. Make sure that you're in degrees, which it probably is not set up originally. So there we go. Now I'm in degrees. And we're saying that we got to do inverse sine, so second sine, of 2 times the sine of 50 degrees. Sorry, I can't have this on my the work on my screen at the same time. Technology, am I right? Okay, so 2 sine of 50, we close our parentheses, then divide by the 3, and we close the other parentheses, drum roll, and we get 30.7, blah, blah, blah. And I said that I typically round to the nearest tenth. Please follow your instructions in my math lab and do whatever they say, whether it's round to the nearest whole or nearest tenth. So we're going to call this 30.7. So B is approximately 30.7 degrees. Now, it is possible that this is the first version of angle B. Remember, the 3 that are prescribed, those are stuck. The 20, the 30, and the 50 degrees, there can't be second versions of those. There can be second versions of what we find, though. So we have to say, is there a second version? So we take the supplement. So 180 degrees minus, let's call that B1 now, because this is the first possibility. And 180 minus 30.7 is going to be 149.3 degrees. But will it fit? Now, there's another way of determining whether this stuff fits, and it has to do with finding the height of this triangle right here. And that's fine, but I'm not going to teach that method. You can look it up on your own. We only have so much time, and this is just a little more definitive in my opinion. All right, so if there's a second angle, this would be it. A second version of that angle, excuse me. But to check that, we want to make sure that the given angle plus this one is under 180. The given angle was 50 degrees. So 50 degrees plus this new second version, this possible second triangle angle, 50 degrees plus 149.3 is 199.3 degrees, which is bigger than 180 degrees, so it's too big. Which means there is no second triangle. So this B is the only version of B. It's not a first version, it's the only version because its supplement was entirely too large to be able to fit into a triangle with the prescribed angle A. Okay, but that doesn't mean we stop here. That just says there's no second triangle. We still have two more things to find. We have to find all the C's. Well, we have angle A of 50 degrees. We have angle B of 30.7. So angle C, that's a capital C, should be 180 degrees minus angle A, which was 50 degrees, minus angle B, which is 30.7 degrees. And if you do that subtraction, what's that? 99.3 degrees. So that's our angle C. Or if you like your Greek letters, that would be our gamma, and A would be our alpha, B would be our beta, which basically looks the same, just with a longer back bottom side of the B, I guess. All right, the only thing left to find is side C. We have the angle, now we can find the side. So since we have one of the two bits of information, we can do the law of sines. So we're going to go back to the completed pair of A's. Yes, B is completed. Yes, we can use that and then deal with the C's as well, but it's more consistent to use the A's because those numbers were given to us and they weren't rounded. This angle B was rounded, so that might not be the best idea to use it. It's going to cause error propagation. It's okay, but it's not great. So the A's, that was the 30 over the sine of 50 degrees equal to the C's. We don't know side C, so that's the unknown little c, over the sine of angle C, which was 99.3 degrees. Now you can cross multiply this and then you'd have to divide by sine of 50 degrees. I'm going to take the shortcut and let's just multiply both sides by that bottom. And once again, I wish I'd left myself a little more room. I got to think about that in the future. So we're going to clear the bottom by multiplying both sides by sine of 99.3 degrees. Let me just put that over here. 30 over sine of 50 equals C over sine of 99.3 degrees. There we go. So that clears out the bottom under the little c, telling us that little c is equal to 30 times the sine of 99.3 degrees. That's just a little ugly. Better. Over the sine of 50 degrees. That's our little c. So 30 sine of 99.3 over sine of 50. Let's go back to our calculator. So 30 times the sine of 99.3. Oops. I clicked twice, but it didn't register. Divided by sine of 50. And we get drum roll 38.647, blah, blah, blah. Rounding to the nearest tenth, that would be 38.6. That is not an angle. That is a side length. So no degrees. Again, we really don't want to use radians with these problems. I'm not saying you can't, we just don't want to use them. I would most likely convert all my radians to degrees if I were ever given a problem like this in radians. I just think it's a good idea because it gives us a little bit more tangibility. All right. So I mentioned that I'd go back and show the calculator for the last problem we did last class. Let's show that real quick. So in problem A from last class, the thing that we had to type was our angle B was going to be the inverse sine, so second sine, of 3, because there was a 30 over a 10, so that reduced to a 3. So 3, then times the sine of 150 degrees. We hit enter, and look at that, error domain. So we talked about last class how the inside, that 3 times sine of 150 degrees turned into 1.5, and inverse sine has a domain that's only from -1 to 1, because the range of a regular sine is from -1 to 1. So we're plugging 1.5 into something that we're not allowed to plug 1.5 in. This is an extremely important issue moving forward that we understand. And again, you've got your calculators, so it's going to tell you when this happens, but there's times when we need to understand analytically why it's happening. Maybe we have to rationalize it for some reason. So again, this is exactly why there was no triangle from example 1A, because our calculator spit out nonsense. That says no calculator. All right, back to the whiteboard. So we saw a no triangle case last time. We just saw a case where there only ended up being one triangle because the second version of the second angle was too big. So if this 149.3 had been like 30 or 40 or 50 degrees, then there definitely would have been a second triangle, because that would have that plus the 50 would have been less than 180. And spoilers, that's probably what we're going to see next. And I'm also going to have a hard time fitting it into one whiteboard, but we'll do our best using two if we have to. All right, C. And we got a little a that's 30. We got a little b that's 40. And then an angle A that's 20 degrees. So this is side angle, because this angle is not between side A and B. It's an opposite angle to one of those. So this is side angle case, which means it's ambiguous. There may be, oops, gotta love technology. I'm a little too high up on the whiteboard. There may be a second triangle, just like last time, just like the one from last class. If we're only given one angle and we have a completed pair, that's the ambiguous case. If we're given two angles, it's not ambiguous. All right, so the first thing we need to do is try and find angle B, since we have the completed A pair. We can't find the third angle by doing 180 minus the first and second, because we don't have the second. So we use the law of sines, which will say A over angle A. So that's 30 over, I said that wrong, A over the sine of angle A. So that's 30 over sine of 20 degrees. is equal to b over the sine of angle b. So 40 over the sine of angle b, which we don't know. That's our unknown. We're going to cross multiply, which will give us 30 sine of b is equal to 40 sine of 20 degrees. We always like our constants in front of the signs when possible. We're then going to get rid of the 30 in the front because we got to solve for angle B. So we'll divide both sides by 30. And we're going to see another one of those reductions. It doesn't always happen, so please don't assume that this is always going to reduce, but yes, the factor of 10 goes away here. So we get sine of angle B is equal to 4 times the sine of 20 degrees over 3, or 4/3 sine of 20 degrees. Now what we have to do, and again, some people will just go straight to the next thing. If sine of b equals this, then b equals the inverse sine of that. But the technical algebraic step is we take the inverse sine of both sides. So we go inverse sine, of sine of b equals inverse sine of 4 sine 20 degrees over 3. The reason we do this is because inverse trig functions cancel each other out. An inverse sine of a sine cancels as long as we're in the appropriate quadrants, which we have to be. Okay, so that tells us that angle B is equal to the inverse sine all of 4 times the sine of 20 degrees over 3. So we're going to need to pull up our calculator. So that's inverse sine. So second sine, that's how we get to that in our calculator. Excuse me. Then 4 times the sine of 20 degrees. Remember, make sure you're in degree mode. I made sure at the beginning and I haven't changed it. Then we close that. And then we're going to divide that by 3. And we close the other parentheses. I will say technically you don't have to close the last one with a TI-83, but it's just a good idea, good habit. Drum roll, hit enter, and we get 27.1 when we round to the nearest tenth, and that's degrees, 27.1. So that's our angle B. But it may be the first version of B. There could be a second version. So we have to say, is there a second version, a second triangle? So that's where we take the supplement. So if there is a B2, it's going to be 180 degrees minus B1. B1 being what we're just calling B for now. If this is possible, I'll go back and label this as a B1. And 180 degrees minus 27.1 degrees is 152.9 degrees. But then we have to ask, will it fit? Is this small enough in conjunction with the prescribed angle to actually make a second triangle? So we have to add the prescribed angle and the second version of the second angle. If that's less than 180, then we're cooking and we got a second triangle. So we take angle A plus B2. That's what we're doing here. So that's the 20 degrees, which was prescribed, plus the second version of the second angle, 152.9 degrees. And that's going to be 172.9 degrees, which is actually less than 180. So a second triangle exists. This is what most students would call the worst case scenario. It's the worst case scenario because this is a longer problem. because not only do you have to find the 3 bits of information for the first version, you got to find the 3 bits of information for the second version. Well, actually, we've already found 2 of those bits of information. We just found angle B1. Again, now that we know there is a second triangle, you need to go back and call this B1. And B2, we found to be 152.9. Let me just write that over here. 152.9 degrees is B2. So that comes from us swinging that leg. Instead of swinging it out on the triangle, we swing it in. And again, that visualization is seen in the last lecture. All right, so now we need to find, let's see, we have the completed pair of A's. We got the B. So again, there's no second version of side A, angle A, or side B. We found the second versions of the B's. Now all we got to do is find all the C's. So we have to have both versions of side C and both versions of angle C. It's going to be easiest to find angle C's first because we have angle A and we have the different versions of angle B. So let's find C1 and C2, the angles, next. Just moving something on my screen that you probably can't see. So C1, angle C1, that's a big C, is 180 degrees minus the prescribed angle A minus B1. To find angle C1, you have to use angle B1. If we were finding C2, we'd use angle B2. There's no 1s and 2s for prescribed values. That's why the A is the A. So that's 180 degrees minus 20 degrees minus 152.9 degrees, which is a very, very small 7.1 degrees. That's angle C1. That's got to be a really small angle. I goofed. I goofed. I'm sorry for that. This is hold on, where's my undo button? I put it down here. I did not use angle B1, did I? I used angle B2. I wasn't supposed to subtract 152.9. I was supposed to subtract the 27.1. That was B1. Sorry about that. I'll give you a second to correct that. B1 was the 27.1. So 180 minus 20 is 160. Then 160 minus the 27.1 is going to be 132.9 degrees. I'm glad I caught that. That's our angle C1. If C2 was that big, I'm sorry, if angle C1 was that small and B's that small and A's that small, those weren't going to add to 180 degrees. That made me realize that really quick. I asked myself if it made sense. And then I knew, nope, I used B2 instead of B1. Now, you could go ahead and find side C1 if you like. You could go ahead and find the other version of C2 if you like. It doesn't matter the order that you do the rest of this information. So a lot of people like to go ahead and complete the second triangle. So let's find C1, little c1, that is to say. So let's find side C1 next. Again, I don't have to do it in this order. I can find angle C2 by going ahead and doing 180 minus 20 minus the 152.9, which we literally already just saw the answer of 7.1 degrees, but I'll come back to that. So to find C1, we'll do law of sines. So the A's, that's 30 over the sine of 20 degrees equals little c1 over the sine of angle C1, which is 132.9 degrees. You could cross multiply and take this the longer way, or you can just take the shortcut and multiply both sides by the bottom of C1. So we're going to multiply both sides by the sine of 132.9. It's just the shorter step. We do that, so the thing under the C1 goes away. So now it just says C1 equals blah, blah, blah. So the left side is now 30 times the sine of 132.9 degrees over the sine of 20 degrees. That's C1, side C1. And when we go to type that in our calculator, oh, that's right, it's down here now. Let me drag this back to the top. So again, we're doing 30 times the sine of 132.9 degrees, close the parentheses, and then we're dividing that by the sine of 20 degrees, close the parentheses. And when we hit enter and we round to 1 decimal place, 64.25, excuse me, that'll round up to 64.3. So that is the length of C1, the first version of side C, 64.3. So angle C1, side C1, and angle B1 make up triangle 1. All the things with the little ones, B1, C1, C1. Those go with the A, and B. Now let's finish out the second triangle. So we can say that our angle C2, that's a capital C, is 180 degrees minus the prescribed angle minus B2, which is 180, minus 20, minus, that's 152.9, all in degrees. And when you do that subtraction, you get, as we saw before, 7.1 degrees. So that's the second version of angle C. It's kind of interesting because when angle B is teeny, that made angle C very large. When angle B was very large, angle C has to be teeny. Then we can do law of sines. We can do law of sines to find side C2. So we'll go completed A's. So 30 over sine of 20 degrees. It's kind of nice how we just keep using that one over and over and over, in my opinion, equals, and now we're going to go with the C's. So that's little C2 over the sine of angle C2, which was the 7.1 degrees. Same thing as last time, at least we're doing the same algebra over and over and over. We're going to multiply both sides by the thing under the C2, which is the sine of 7.1 degrees. Just kind of do that. That way, C2 is isolated. And we get that 30 times the sine of 7.1 degrees divided by the sine of 20 degrees. That will be equal to little C2. And then we'll put that in our calculator. So that was 30 divided by, sorry, no, not divided by, 30 times the sine of 7.1 degrees, close our parentheses, then divided by the sine of 20 degrees. Drum roll, close our parentheses, then the drum roll. And we get 10.84, blah, 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 rounded to the nearest tenth, that would be 10.8. That is a side length, so please do not put degrees on that. Paper pencil test. Paper pencil test, you would lose credit for that, which is not fun. Nobody wants to lose credit. So what some people might like to do just to gather all their information is to write all this out and have triangle 1 and triangle 2 all completely separated instead of just having everything littered everywhere. And it's fine this way. I give people full credit for that. But what you might want to do is just, all right, so continued. Triangle 1, that was the little a, that's a colon. The little a was the, sorry, I gotta pull up my notes. 30, little b was 40. Angle A was 20 degrees. That was the prescribed stuff. Then we found angle B1 to be 27.1 degrees. We found angle C1 to be 132.9 degrees, and then side C1 to be 64.3. Then triangle 2, again, the A was still 30. The B is still 40. The angle A is still 20 degrees. But B2, that was the supplement of B1, that was 152.9 degrees. Angle C1 was that, sorry, C2. I was looking at C1, pardon me, was 7.1 degrees. And then side C1, the very last thing we found, was the 10.8. So there's everything packaged up together. And again, you don't have to do this, but it just might be helpful for your understanding. All right. So we have now seen all 3 of the different cases. The case we did at the end of last class was the no triangle case, because in trying to do that algebra and trig to find that angle B, the second angle, our calculator said, nope, undefined, does not exist, error in the domain. And that was because we were putting a number into an inverse sign that we can't put into it. Then we had example B, which was one triangle, because the the supplement of angle B was too big to fit into another triangle. Example C, everything worked perfectly to make our 2 triangles, and we saw that the work was significant. Now, because that was a more challenging problem, I do want to do another one. Let me say probably, but you know how I work. So, D. Move this for a minute. So let's go with A equals 7, B equals 28, and I'm going to use the Greek letters now. Let's go with angle alpha is 12 degrees, so that's the same as a capital A. That is the exact same thing as a capital A. Oop, that's not what I want. There we go. Again, alpha, this is the Greek letter alpha, that's the same as a capital A. So this is, that was weird. Why is my draw not working anymore? There we go. It was being weird. This is side angle again, because the angle given is not between these two. It's not angle C. That would be between the two. This is completing a pair of information. So that says law of sines. So we use law of sines to find angle B since we have side B. So we go 7 over the sine of 12 degrees, that's A over sine A, equals B, which is 28, over the sine of angle B, which we're now calling beta. It just has a little bit longer extended back, bottom, whatever you want to call that. At least the b and the beta look very similar to each other. We're going to have to cross multiply this. There's no single shortcut for this one. So that gives us 7 times the sine of beta equals, I'm leaving myself some space, 28 times the sine of 12 degrees. And then we're going to take, and again, you can shortcut this. Take the inverse sine of both sides. If you, oh, man, I'm sorry. Are we ready to do that yet? No, we're not. Why not? Because of the 7. We have to divide by the 7 first. I didn't need that space yet. I got so focused. So the 7s cancel on that left side, and we get the sine of angle beta is equal to, and again, 28 divided by 7. This does not have to reduce, but it does, to a 4. So that's 4 sine of 12 degrees. Now we take our inverse sine of both sides. I couldn't do this with the 7 in front because an inverse sine of 7 sine, they don't cancel. It has to be the same thing back to back. There we go. The inverse sine and the sine cancel, so we get the angle beta is equal to the inverse sine of 4 times the sine of 12 degrees. And once again, don't always expect this to reduce. You can leave it as 28 over 7 if you like. You're going to get the same answer because you're putting in a calculator. And let's put that in a calculator. Let me clear my screen. Things getting a little messy up there. So we're doing the inverse sine, so second sine. Maybe I should check my mode just to be safe. I haven't done that in a while. Yep, we're still in degrees. Okay, second quick. So inverse sine of 4 sine of 12 degrees. 4 sine 12 degrees, close all our parentheses, drum roll, and we get 56.268 blah, blah, blah. So rounded to the nearest tenth, that would be 56.3 degrees. 56.3 degrees. So that's angle beta, but it may be the first version of this because we have to ask ourselves, is there a second triangle? I'm gonna write it here. And if there is a second triangle, it means that the supplement of this angle would be in the second triangle. So we take the supplement. If there is a B2, a beta 2, that has to be 180 degrees minus the first version, which we just found is 56.3 degrees. Again, I'm not labeling this as B1 initially. I only put the 1 there if I do find out there's a second triangle. So I'm saying if this is B1, then we do 180 minus that, and 180 minus 56.3 is 123.7 degrees. But then we ask, will it fit? So the prescribed angle alpha plus the second version of the second angle have to add to less than 180 degrees. So alpha plus beta 2, that's 12 degrees plus 123.7 degrees, which is 100. Sorry, I'm looking at something. 135.7 degrees, which is less than 180. So yes, it will. There is a second triangle possible. So now we go back and call B B1. So what I had as beta originally, now I am definitively saying that's B1. because the second version fit. So B1, beta 1, was 56.3 degrees, and this 123.7 was angle beta 2. Okay, so we're going to have to go through and find all the C's, but there'll be two versions of each of them. The angle is going to be the easiest thing and the only thing we can find next. So we got to find C1 next. And to do C1, can I move this thing? Yes, I can. All right. To find angle C1, that's 180 degrees minus the prescribed alpha minus what we found for B1. And this is an alpha, not a 2. So that's 180 degrees minus 12 degrees minus 56.3 degrees. I'm not going to make that mistake twice. And that turns out to be 111.7 degrees. So that's the first version of angle C. Now, yes, we could go ahead and find angle C2 by doing 180 minus alpha minus beta 2. But I just kind of feel like it's nice to go ahead and complete the triangle since we can. So we can find little c2 by using the law of sines. Little c1, I think I said c2 there. We can find little c1 by using law of sines with angle c1 as well as the a and alpha. So we go 7 over sine of 12 degrees, literally the same left side from before, equals little c1 over the sine of angle c1, which is 111.7 degrees. We're going to cross multiply. I'm sorry, we're not going to cross multiply. We can, but there's a quicker process, as we know. We can just multiply both sides by the bottom. It would not have been wrong to cross multiply. It just would have taken 2 steps instead of 1. And when I say multiply both sides by the bottom, I mean by the bottom of the variable side. We don't care what the bottom is on the left side, just the right side, because there's a variable with it. We need those to go away like that. Put the sign of 111.7 after the 7. So we get that 7 sine of 111.7 degrees over the sine of 12 degrees. That's equal to little c1. We'll need our calculator for that. So 7 times the sine of 111.7 degrees, close it, divided by the sine of 12 degrees. Drum roll after we close our parentheses, and we get 31.28 rounded to the nearest tenth. That would be 31.3. 31.3. So this information was completing triangle 1. Now let's complete triangle 2. And again, we already have one part of triangle 2. That's the beta 2. So triangle 2, next thing we need to find is angle C2, which would be 180 degrees minus alpha minus beta 2, which is 180 degrees minus the 12 degrees minus, we said beta 2 was 123.7 degrees. And when we subtract that, we'll get, let me put it down here, 44.3 degrees. And that's angle C2. And I've actually been using C's for the capitals instead of gammas. But that should really be a gamma 2, and this should be gamma 1 earlier. And when I put all the information together, I will make sure I write those with gammas instead of capital C's. Then little c2, we're going to find, that's supposed to be a colon, by law of sines. So the completed A's, so 7 over sine of 12 degrees. Once again, I like that we at least are using the same left-hand side of this every single time. Equals, now let's deal with the C2 and the gamma 2. So little c2 over the sine of big C2 or gamma 2, whichever you're calling it, which was 44.3 degrees. And to solve this, you could cross multiply and divide, or you can just do it in one step, as we've seen several times, multiply by the bottom of the variable on both sides. So we can multiply both sides by the sine of 44.3 degrees to cancel that denominator. And that'll tell us that 7 times the sine of 44.3 degrees over the sine of 12 degrees is equal to little c2. And that's not like a little gamma 2. The sides are always A's, B's, and C's. And we'll put that into our calculator. It's funny, my pen doesn't like to work with the calculator. I have to go back to my mouse. So that's 7 times the sine of 44.3 degrees, close the parentheses. 7 times the sine 44.3 degrees, then close the parentheses, divided by the sine of 12 degrees. Look how similar that is to the last thing we typed into our calculator. The only thing that changed was the angle inside of the top sine. The 7's still there in the top. The sine of 12 degrees is still in there in the bottom. We make sure all our parentheses are closed appropriately, drum roll, and we get 23.5 when we round to the nearest tenth. So we know we're done because we have 1, 2, 3, 4, 5, 6 answers. With 2 triangles, we double the number of answers we're supposed to be finding. You might think, oh, well, with 2 triangles, that means there's 12 unique values. And you're half right, because these 3 values are repeated. So these 3 values are in triangle 1 and triangle 2. So that's actually now 6 of the sides and angles. There's just overlap. So again, this is perfectly fine how we've answered this, but if you just wanted to be a little more organized and have all of triangle 1 information together, it still has the A as 7, the B as 28, and then angle A as 12 degrees. Then the things that we found beta 1 to be 56.3 degrees. Then we found angle gamma 1, which was what I called capital C1 initially. I apologize for that. That was the 111.7 degrees. And then little c, so the side, C1, was 31.3 in length. For triangle 2, again, the prescribed stuff is the same. The A is 7, the B is 28, and angle A, oh, man, I just couldn't get this right, could I? That's alpha. Pen. This multitasking with this pen is going to be the death of me. I'm sorry. Whole new world. So alpha was still 12 degrees. Then we found beta 2. That was the 123.7 degrees. Angle gamma 2, which was the capital C equivalent, that was the 44.3 degrees. And then little c2, That was the 23.5. There we go. Everything is as it should be written there. Isn't this fun? All right. Now, I'm trying to make a decision here. Yeah, I'm actually going to cut class a little early today because the next topic of this section is to find the area of an oblique triangle. So let me just kind of talk for a minute or two, not officially covering anything, but next time. So old, if you were given a right triangle, I'm sorry, not necessarily a right triangle, but if you were given a triangle where you knew the height and the base, the area was equal to 1/2 times the base times the height. And the logic and reasoning was that this triangle is half of a rectangle, and the rectangle would have a length of b and a width of h, or vice versa. What we're going to see next time we are not going to be given the height. So we're going to have a new formula, and I'm actually going to put a parentheses s with that because there are 3 formulas, however, they are all the same thing. Kind of like how our law of sines has 3 parts of the equation, even though we only ever use 2 at a time. The next section, I actually feel like this topic goes better in section 2 than section 1 because of the information prescribed. Everything that we did in this section, we were not necessarily given, if it was a single angle given, it wasn't the angle between the 2 sides. The next section, that's when we're going to be using law of cosines. That's when we're given the angle between the 2 sides. And in fact, the formula that we'll use in this case is the same conditions. So I believe the textbook company companies put this formula in the law of sines section because the formula has a sine in it. However, the setup is more in line with the setup for law of cosines. It doesn't matter that the formula has a sine in it, it goes with the setup. So what will be given instead of, say, a height and a base, will be given, let's say this was our triangle. We might have this angle A, or alpha, and then side lengths of B and C. This is what I call a corner of info because it goes side, angle, side if you go, in the shortest path possible. Side, angle, side. This is SAS. This is what's used for law of cosines, which is a bigger, crazier formula that I do expect memorization of. But it also enables us to do the area of a triangle without actually knowing the height. And in fact, what we do is we find the h here. This value is findable if you just project that line down there and make a little right triangle. And then you can figure out what this side is based on side length B and angle A. Spoilers, you use a sine to it. So this height is, that does not say his, h is findable just using SOHCAHTOA. And that's what gives us the 3 versions of the formula. It just depends on what letters you use. So that 1/2 is still going to be there. The base and the height are still basically there, but it's just a little something different. So I'm going to go ahead and call it a day on the lecture, a little early, just because I don't feel like it's going to benefit us to start this now. When's our review due? It's not due. When's our homework due? Thursday night. When's our test due? Friday night. Get on this stuff. Please don't start this chapter 7 homework. I wish I didn't have to lecture while a test was coming up, but this is the way it works in regular class too. We're always lecturing ahead of the test to keep up with things. Remember that I'm being very generous. I'm giving you 2 attempts on this test. So please take my generosity and run with it. Use the first run through it as a kind of a study guide. You will have seen the questions. I picked the same questions for both versions. So if you can take the first version of it earlier and say, oh, okay, well now I know what questions are on it. I can go back and study these even more. Maybe you'll do better on the second attempt. Again, please complete these to your best of efforts. Get the homework done as well. Besides that, if you have any questions, please email me. Remember, there is a discussion board set up. If you have any questions with homework, please do not use the discussion board for tests questions. Obviously, I will see that. And well, obviously we'll handle the situation if that happens. Besides that, have a good day, have a good weekend. We will see you back on the internet bright and early on Monday. And remember that these lectures go up on YouTube and then in Canvas same day. I try and get them before my next class, but everything takes a little bit of time to upload. I've always had these up by noon. That way, in case there's anything I go too quick on, you can pause, you can rewind. So this is an excellent, excellent resource for us to have, because in the past, you couldn't rewind my lecture. So use that to your advantage. I apologize for the couple of mistakes we made today. I'll try and make sure that doesn't happen again, but the multitasking over here is definitely fun, as I'm sure all of y'all are dealing with as well. I know it's not just me. So stay strong, stay positive. We can get through this. Remember to keep checking your emails. Some emails were sent out about grading for the semester, so please look into that so that you understand what is going on moving forward. Have a good day.